Good morning, everyone. Good morning, am I audible? Hello. Okay, so today we'll be talking about in the building section we have done our flat slab, and now we'll talk about today we'll solve a problem on stairs. You already have, I think you have gone through stairs in your previous semester maybe. So we'll take a question on staircase today. So where is my So if we take a problem on stairs, before we take a problem on stairs, I think you all know what is riser, what is tread of a staircase. Okay. So in generally in residential buildings, we consider our risers to be between 150 mm to 200 mm. This one, if I say in a staircase, these are your risers. This one. These vertical portions are your risers, and these horizontal portions are your tread. I think you all know that thing. And that this tread ranges generally in residential buildings. This tread ranges from 200. This one I'm talking about. Sorry. This one. Okay, whatever. So this horizontal portions are known as your tread, and that ranges from 200 to in generally this tread dr this treads ranges between 200 mm to 300 mm. Then we have risers. Your risers will range from 150 mm to 200 mm. Okay, and also so these are generally in residential buildings. So these are the ranges which we consider for tread and risers. We can take any values for riser one between 150 to minimum it should be 150 and maximum 200. Okay. So depending upon this range, we also have some these things like for public buildings. Generally in public buildings, our risers, if I say here, our riser, suppose I'm taking our riser is taken to be 150 mm. Okay, and our tread is taken to be tread is taken to be 270 mm. This was for public buildings and also some maybe in some factories, etc. or go downs, you can say. Okay, maybe factories or some this business areas. Okay, where heavy these things are done. Equipments or some heavy load materials are carried through the stairs, maybe sometimes, or some short floor, like from this floor to that floor, or maybe from this portion to that portion. You have to take carry those machines or maybe heavy loads from those structure. What is that called? From the stairs. So what in those factories we generally take our riser to be generally 190 mm. Then again for if you see tread in those this factories, etc., your treads generally it is taken to be 250 mm. Maybe in cinema, when you are going to theater or some cinema halls, etc., those there your tread generally it is about 270 mm, and your riser it may be about 150 mm. Generally these are taken because this is our range where your tread minimum tread value is how much? 200 mm, and your riser sorry, and maximum is 300 mm, and for riser it is 150 mm to 200 mm. And also let me type here only width of the stairs. Okay, that means this is your stairs from the side view if you're looking, but if you see the plan, then your stairs will be, suppose if I take it to be, your steps will be seen in this way. If you see the plan, you'll see in this way. So this width of the steps is how much? This is between 100, 1100 mm to 1600 mm. Okay, this width of the stairs is generally taken it to be 1100 mm to 1200 mm. Sorry, 1600 mm. And also the thickness of the waist slab. When you have this is your waist slab, this one, your slab is constructed over this, and this is known as your waist slab. This entire thing is known as your waist slab. Okay, so what is your waist slab? Thickness of the waist slab. Yes, the thickness of the waist slab. Thickness of the slab, we take it to be, the range is between 1 by 20 times to 1 by 25 times of the span. Okay, so this is the thickness. This is the thickness of the waist slab, which is taken 1 by 20 times to 1 by 25 times of the span of your this thing stairs. Okay, so when we go to the question, what will happen? This is our question. We'll take a simple one question for our stairs. Okay, in designing our stairs. Also some MCQs I'll be sharing later for all the pre-stress, etc. Okay, this so let's go with the question. Here in the question you'll see designer design a dog-legged stairs for an office building in a room measuring 3 meter into 6 meter. Floor to floor height is 3.5 meter. The building is a public building. Okay, the building is public building liable to overcrowding. Okay, staircase are supported. This is overcrowded building. Okay, public building. Generally, we know our riser we take for public buildings to be 150 mm and treads to be 270 mm. Okay, staircase are supported at brick walls 230 mm. Okay, brick walls thick at the end of the landing. Okay, on the side of the landing over brick walls, our landings are provided. Use M20 concrete and Fe415 grade of steel. So here, what we'll take in this question, we have a public building here. We have to design a stairs case for a public building. We know for a public building it was generally R was 150 mm, the riser, and the tread was 270. So we can assume our riser to be 150 mm here also, but since this is overcrowded, we will try to keep the tread 270 mm. Oh, sorry, it is generally 270 mm. So we'll take little bit more. We can assume because our tread we know it is between 200 to 300. So let us take the maximum value for this particular question now. We'll assume the tread to be 300 mm and the riser to be suppose 150 mm. Why tread we are taking it to be this tread horizontal portion to be more this thing 300 mm this one because there will be this is overcrowded, so we'll take the maximum one. Okay, so if we solve now this question, so these are the given questions we know, which is the size of the room is provided to you. Size of the room is given. Height of the floor we know it is how much? 3.4. Okay. So this was size of the room this much. Height of the floor is given to us to be this one 3.5 meter. FCK is 20 Newton per mm square because I'm 20. FY is given to be Fe415. FY is Fe415. We know for the public building our riser to be 270. Right. Sorry, this is written wrong. So here, if you see, we are assuming here in our question our riser to be how much? 150 and the tread we are taking it to be 300 mm. I told you because it was an overcrowded public building, so we are trying to keep it safe and we are trying to take the tread to be 300 mm. Okay, so that means if this one is our steps, so this is our how much? The tread, this one we are taking it to be 300, and this vertical one, the riser we have considered to be 150 mm. The height of the flights is how much? 3.5 by 2 because our this was our height of the floor. This one 3.5 was our height of the floor. So if we divide it by 2, we will get this steps in this way. This side one step staircase, this side is one stairs. Right. So this was the height of your floor. So if we divide it, we will know. If we divide this floor height, we will know this is the height of one flight. Right. This is the height of one flight. So it comes out to be how much? 1.75 meter. Okay. So now number of risers how to we know this is our 17 this one. Okay. Okay, so the number of risers is how much? We know this is our 1750. 1750. So this one was 1750. Number of risers will be how much? If we divide this floor by the tread, the riser, if we divide, we will get the number of risers. So we got it to be 11.6. We got it to be 11.6, so it cannot be half, we know. So 12 numbers of risers will provide 12 number of risers, and generally the number of risers is restricted to maximum 12 numbers. Okay, it generally we restricted to 12 number of risers. And then treads will be one less than your number of risers. Okay, because you see here, if this is your riser, one, two, three, four, five, and what is your tread? One, two, three, four, five, and here again one riser will be there. So six risers and five treads will be there. So one always it is tread is one less than your riser. So in this particular question, we got our riser to be how much? 12 numbers, and our tread we have got to be 11 numbers, right? Because it is one less than the risers. Now the total length of the tread we can calculate. The total length of the tread, if we see, the total length of the tread will be 300 was our tread, 300, and there are 11 numbers of threads. So the total length of this thread, these threads are here given to you. So the total length of the threads we got it to be how much? 3300 mm. This one, 3300 mm. This portion with the threads, the total length with the thread is 3300 mm. Now if we see here the plan, see here, this two are the flights, right? This two are your flights. Then we have this are your landings. This side one, this side one, and this were the brick walls. It was mentioned in the question. Supported at brick wall 230 thick at the end of landing. Okay, so brick walls were present here both sides. This side, which was 230 this one, thickness of this brick wall was 230 Now we got the length of our treads. These were our treads: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 treads were there. So 11 it will be. Okay, one more is going to come here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One is going to come here more threads. So there are 11 threads. So the length or total length with the 11 threads was how much? This one 330. That means this 3.30 meter. This was your length of the threads. And what is the length of your this? Now, if we see the total length of the threads, we have got this one 3.30. Now, if we see the width of the landing, this width of the landing, how much should be the width of the landing? That will be, we know our this thing, how much was the size? Size was 6 meter, 3 meter into 6 meter. So this was 3 meter. This was 6 meter from the center to from here. Sorry, this portion from here, from this starting of the landing to this starting of the landing, this was 6 meter. So now 6 meter, if we subtract from the 6 meter this 3.30, that is the total tread, and divided by 2, we will get this distance, this portion and this portion we are going to get. So that is how much? That comes to be 1.35 meter. 1.35 meter. On both the sides we got the width of the landing. Okay, now if that means in the first step we have done what? In the first step we have just assumed the threads, risers, and then height of the flight, how much will be the height of the flight, etc. And on the second step we have done the number of risers we have calculated. Okay, in the second step we have calculated the number of risers, threads, okay, width of the landing, these width of the landings. Okay, Now in the step number 3, this will be your step number 3, where we will design for staircase. In the step number 3, we will design the staircase. In the step number 2, we have calculated the tread risers. Sorry, we have calculated the this length of the treads, total length of these treads, and the landing width. Then again, how much is from here? If this is 230 mm, the brick wall thickness is 230 mm, then the this thing is how much? The effective span of the stairs is how much from here, from the center of this wall to the center of this wall. That means we know this portion, this was 3.30, the landing width was 1.35, 1.35. So that means total it was from here to here, it was 6 point, sorry, not 6.23, but total from this center of this wall and center of this wall, that means 3.30 plus 1.35 plus 1.35 plus 0.23, this one. So this one, that means nothing but 0.23 by 2, 0.23 by 2, that is plus, you can directly add to be 0.23. So it gives us to be 6.23. That means from here the effective span is how much? This much of the flight. Now what we'll do is we'll have find out the thickness of the waist slab. I have told you that what was the thickness of the waist slab. Thickness of the waist slab was 1 by 20 times to the 1 by 20 times to 1 by 25 times of the span, this effective span. So if again we go, you see here the thickness of the waist slab 1 by 20 times, we have taken the minimum one, 1 by 20 times of the span. So this was our effective span. So how much is your thickness of the waist slab? It comes out to be this much, 0.3115, 0.3115 mm. So we can consider it to be 311.5 meter. This was in meter, so 311.5 mm. Okay, just calculate this here. I think this will be this 1 by 6.23 divided by 20. This will be your 0.3115 meter. That is nothing but 311.5 mm. Okay, so this was our thickness of the waist slab. Thickness of the waist slab, we mean that suppose if we see this is our waist slab, this one, and our step is in this way. Step is in this way. Here we have our riser, we have taken it to be 150. Our thread, we have taken it to be 300 mm. And here the this one, the thickness, this is the this one is your thickness of the waist slab, which we have got to be 300, this one 311.5 mm. And if you want to increase the slab weight, you can also take it to be 320, round off 320 or 325 mm, this thickness of the weight slab according to your design, you can consider that. So we have calculated thickness of the waist slab. Okay, this is the plan. Now the next step, if we go to the next step, which is the load calculation step. Okay, This is the 4 number step where we are going to consider the loadings. Okay, so I pause this annotations. Basically, when we are calculating the loads, which are load calculation, when we are performing, when we are calculating the load calculations, we know that the what happens, your dead load or the load on the staircase of a dead weight of waist slab and dead weight of the steps consist. Actually, your dead load will consist of your this load of the waist slab and the dead load of the ceiling finish. Oh, okay, 1 minute. In the question, I think I have missed something. The ceiling finish. Consider in the question you can add there like the ceiling finish. Consider the ceiling finish to be 12.5 mm. Okay, you can add here in the question. Maybe it is not mentioned here. Yeah, I forgot. Here he also have forgotten this today. So you can add here in the question. Consider ceiling finish to be 12.5 mm. Okay, add this to the question so that it is provided it will be easy for you. So 12 mm, consider the ceiling finish to be 12.5 mm and the M20 concrete and Fe415 grade of steel. Okay, so now we will know that the dead weight or the load on the stair consists of our dead weight of waist slab and also the dead weight of the slabs. Now the dead weight per unit area, if we first calculate at right angles to the slope at the waist slab, this one, first of all calculate the dead load of the waist slab. Here we know the this thing thickness of our waist slab was how much, 0.3115. 0.3115, and we know the unit weight of concrete is how much, RCC concrete is 25 kilonewton per meter cube. So we got our dead load of the waist slab, which is coming from the waist slab is this much, and the dead load of the ceiling finish will be how much, 24, which is the unit weight of plain cement concrete into our this thing. The floor finish is sorry, the ceiling finish was given to us in question 12.5 mm thick. So in meter it is this much. So the dead load of the ceiling finish comes out to be 0.3 kilonewton per meter square. So now the dead load from the waist slab plus the ceiling finish gives us to be comes out, or you can say comes out to be this 7.7875 plus our 0.3 kilonewton per meter square. So the total dead load will be this much. Okay, our total dead load will be this much. Now, one more thing, like the as I told you here, if this is your weight slab, this is your weight slab. Here we have these are our steps. These are our steps here. So this will be our, we all know this is stride, this is waist, this is risers. Here the dead load of the waist slab, this one we have calculated to be this, and the ceiling finish here we have calculated to be zero point 0.3 kilonewton per meter square. So the total dead load from this waist slab and the ceiling finish is 8.0875. Okay, so that is the dead load per unit area is first calculated right angles to the slope of the waist slab. Okay, right angles to the slope of the waist slab here. The corresponding load, that means the corresponding load per unit, this horizontal area is then how much obtained by, we will obtain this load per unit horizontal area to be after multiplying it with this total dead load. Okay, That means the corresponding load per unit per span, per meter span on the plane with the waist slab and the ceiling finish. Actually, it is given by the ratio of this one. Root over r square plus t square by the t. Okay, so that means corresponding load from this, okay, waist slab plus ceiling, this also including, so it is given by this root over r square plus t square by t, and we will get our load, the total load per unit, this horizontal area by multiplying it with this total dead load, where you will have your r is nothing but the riser, t is your tread. Okay, hence our total dead weight of the slab per unit horizontal area is given by how much? This much. This is our total dead weight of the slab per unit horizontal area. This one. Okay, we'll calculate the dead load from the waist slab, dead load from the ceiling finish, and then this is the total dead load of the waist slab plus ceiling. Now, horizontally, if we calculate the total load per unit horizontal area, this one, this ratio root over r square plus t square by t must be multiplied with the total dead load of the this slab waist plus ceiling waist. Okay, so this gives us to be how much? If we see, this is how much? This comes out to be, if we calculated, we got it to be 9042.0. Okay, Newton per meter square. So again, once we know this is the corresponding, this is important for us, this is the corresponding load. This we have already calculated, but what is our corresponding load which is acting horizontally is this load. Okay, this one. So now again, if we calculate the dead load of the step, dead load of one step will be how much? The area of the triangular portion half into base into altitude by the tread per unit tread, per tread will be how much? Half into 300 the tread into riser, the area, the dead load of each step. Earlier we have calculated the dead load of the waist slab with the ceiling finish, and now the dead load from each step is going to come out this much, 1 point per meter, 1.1875 Newton per meter square. Okay, so this is what we got. One which important dead load is one from the step, one from the corresponding base slab and the ceiling which is acting horizontally. Okay, and another one is our top finish. One, we when we have the stairs with the waist slab, there is also a top finish above the waist slab. So that also is how much? That is 12.5 mm. The just given in question, right? The finishes are how much? 12.5 mm. So that is how much? This one, 0.0125 mm into our, sorry, 0.0125 into 24 the plain cement concrete. So that comes out to be 300 into 300 Newton per meter square. This is meter square. So the total load will be how much now? These were in mm square. So this is in mm square. So total dead load will be how much now? This one. Total dead load is our the corresponding load which we had calculated from the waist slab and the ceiling finish, and then we had calculated the dead load from steps, triangular steps, and this is the top floor finish above the waist slabs. Okay, and the steps. So this is the total, actually the dead load. Okay, now we have also life load. I think it is mentioned in question. The life load is given to be this much. Okay, 5000 Newton per meter square, similar to this. So the total dead load will be how much? This much, right? So our total dead load will be 161217 Newton per meter square. So here the factored load will come. We can calculate the factored load now once we know the total dead load, 1.5 into this much, right? So once we have calculated, now we can calculate our moment, maximum bending moment, then the area of reinforcement. Okay, not much is left. So calculation of moment, if we do here, we know our total factor load comes out, have come out to be this much per meter square. Now the bending moment per width of the stair will be how much, since it is this UDL, so WL square by 8. So W we know our this thing, the factored load, this much. L is the total effective span we had calculated, it was 6.23 from the center of the brick wall to the center of the brick wall. So we got our this to be how much? 118.01 kilonewton meter. The total bending moment per meter width of the stair. Now the maximum bending moment allowed for a singly reinforced section will be how much? This maximum is given by 0.138 FCK into BD square. FCK we already know. Okay, so with per meter we have considered, so 1000, and D is the total effective that. Effective that I told you, it was 311 point something. So you can maximum, since we are considering, so we can take it to be some more somewhat more. So 311 we can take it to be 320 or 225, whatever you want. The depth of the that slab, waist slab. Okay, for finding out this maximum bending moment which is to be allowed. So now after that we'll come to the area of reinforcement in the next step, which is calculated by this formula. Mu, the maximum bending moment, is 0.8 into Fy AST into D root, whole into 1 minus AST by BD into Fy by FCK. So Mu we have already calculated here, the maximum